Hello. Okay, we're going to do our last lesson and we're going to be talking about density. Well, I don't want to say our last lesson, but almost our last lesson, okay? And we're going to talk about density. And density is nothing more than mass divided by volume. A lot of times we'll say D equals mv, but I want you to see that this mass is in a unit, usually grams. It could be all sorts of measurements of mass divided by volume and its units, cubic centimeters, millimeters, any type of volume you want, liters, whatever. This is nothing but a ratio and proportion, okay? In the last video that you saw from YouTube, the guy did a great job of explaining why does he flip these over, because it's just one unit over the other, and depending on what you're trying to find. When we were talking about radians and degrees, what did you want to keep? Put it on top. What did you want to get rid of? Put it on the bottom. So that's what he's basically doing. If you want to keep your centimeters, put them on the top. Get rid of the grams on the bottom. And that's exactly what he was doing. But it is really nothing more than a ratio and proportion. But what I also want you to understand is that density can be any type of density. It could be the density of how many cars are on the road. 9 o'clock traffic, there's a larger quantity of cars on the road, say 50 cars for every 40 feet, okay? That's a high density. In the middle of the day, when everybody's at work or coronavirus is going on, the density of cars on the road is much smaller. There's maybe 10 cars for every 40 feet. So you can do density in many things. It doesn't have to just be grams and centimeters cubed. It can be cars over total highway space. Another type of thing that we can compare is rate, distance over time, distance in meters or miles per hour. You've heard that a lot. Miles per hour is comparing the miles and how long it takes you to get there. That's what gives us a rate. So the density, or how fast you're traveling, is miles per hour. You can do population density, how many people compared to how much land space you have, how much volume. You could be building a birdhouse. How many birds fit in the birdhouse? How big is that birdhouse going to be? So you can do density many different ways. It's not only just grams and centimeters cubed. So I wanted you to hear that and to see it. The video shows you how to do some flipping and comparing. I'm going to show you how to set it up as a ratio and proportion. Plug in what you know, solve for what you want. Okay? All right, so let's take some of the same exact problems that he did his way, and I'm going to show you how I do them my way. Okay, so here we go. A piece of granite rock has a mass, so they're giving you here the mass, and a volume. So what is the density? So all you have to basically do is set up your formula. Density equals mass divided by volume. Cross multiply and solve. Okay, so the density equals, what is your mass? 15.5 grams over the volume, which is 6.01 centimeters cubed. So basically all you have to do is divide this. So density equals 15.5 divided by 6.01 equals 2.579 grams per cubic centimeter. Okay, and the thing that he did is he said, hey, there's three significant numbers, so make sure you have three significant numbers. I kind of like that, but it always depends on how the problem asks you to give your answer. But since he taught you that way, let's go ahead and look at this. 3 significant numbers. We're moving this over to 2.58. But I want you to see it's grams per cubic centimeters. So you're just plugging it in. Same thing for the next one. Distance equals mass over volume. Gold has a density. So what are they giving me? Density. And that density is grams per 1 cubic centimeters. If you have a gold bar with a volume, so here they're giving you the volume. So just simply plug in what you know and solve for what you're looking for. They give you the density, so it goes in for D, 19.3 grams per cubic centimeter. 1 cubic centimeter equals, we're looking for the mass over the volume. The volume is 44.9 centimeters cubed. Simply cross multiply. We have mass times 1 cubic centimeter, so we have mass of cubic centimeters equals 19.3 grams per, which means times to get the mass alone, we would divide by the cubic these will cancel out. We have mass equals, then you take 19.3 times 44.9. You have 866.57. These cancel out. This was 19.3 grams. I forgot to put the G in there. So your mass is nothing more than 866.57 grams. Okay, let's do the last one. Isopropyl alcohol. Again, we're talking about density equals mass divided by volume. Isopropyl alcohol has a density of, and now they're giving me the density. How much volume would the taken up with 50 grams of isopropyl? So the 50 grams is my mass. So we end up plugging in what we know. So again, 0.785 grams per cubic meter, 0.785 grams over centimeters cubed equals mass, they're telling me is 50 grams over volume. Cross multiply. We have volume times 0.785 grams equals 50 grams times cubic centimeters. Divide each side by 0.785 grams. Divide by 0.785 grams. The grams cancel out. We end up with centimeters. And 50 divided by 0.785 equals 63.69 centimeters cubed. And there you go. Don't make this any harder than it is. I want you to think, what types of density are they talking about? Are they talking about just grams and centimeters cubed? Are they talking about distance and time? Are they talking about people and land? Are they talking about fish compared to how much water is in a tank? That would be fish density. You pick and choose what kind of density you want to find. When you do your project, planting a garden, how many plants per square footage of soil do you have to work with? Make it real. Apply what you know and make it happen. All right, kiddos, have a good one.